Good morning, students. Yes, students, in last class we were doing revision. We have completed the revision of fourth module. Now we'll begin the revision of fifth module. Yes, students, is the screen is visible? Can you see the screen? Is the PPT is visible, students? Please respond.
Yes, ma'am, we can see.
Okay. So this is the fifth module. In the fifth module is here we are going to learn what is fault-based testing, planning, monitoring the process, and document analysis and test. One second, students. Yes, students, in this fifth module, we are going to learn fault-based testing, planning, monitoring the process, and document analysis and testing. So this is a prescribed book. So, this book you have to refer for this module. That is software testing and analysis, process principle and techniques. So, the model of potential program faults is a valuable source of information for evaluating and designing a test suits. So what happens? So when we develop any program, what happens? First, we need to check what are the faults. How we check, students? How we check the fault? How we check the fault? When we test the program, only then we'll come to know what are the faults in my program. Faults are nothing but the errors in the program. And generally, before we run the program, so we set a hypothesis. Hypothesis is nothing but some assumptions. So what, assume that I have developed a website for our department, so automation of MCA department in BMSIT. If I am developing this application or this project, so what I do, when before the development, I take a requirement from the department, because I am developing this application or software for the department. So I take the resource requirement. So when I take the requirement, so I will assume that like this I have to develop the project. Correct? No? Like this I have to, these are all the requirement from the customers, or these are all the requirement from the end user. So to satisfy this requirement, I have to develop the website, or I have to develop the project or application like this. So like in the beginning only they set the they set some assumed picture. They assume some picture. That assumption is nothing but the hypothesis. So once we develop a project, so we'll check that whether I am able to reach the hypothesis. Whether I am able to reach the hypothesis. If not, then what are the faults are there? Because of what faults I am not able to satisfy my hypothesis. So that we have to check. So when we are able to check whether we are able to reach the hypothesis or not, when we test our project. When we test our project, then we'll come to know the hypothetical faults. So we'll come to know what are the faults are there in my project. So that will come to know, and based on the fault, so to prevent the failure, to achieve the success. So the engineer, what the engineer here you can see. So here the engineer, they study the failures. They study failures to understand how to prevent the similar failure in the future. So if now maybe I have not taken the resources properly, or maybe I have not taken the data, I have not designed the database properly. So what are the mistakes we are doing in this project? So we have to see that where I went wrong, what mistakes I have done, so that I can understand the failure and I should not repeat that in my future projects. So assumption and fault based assumptions in fault based testing. So sometimes so the effectiveness of fault-based testing depends on the quality of the fault model and some basic assumptions about the relation of the seeded fault to faults that might actually be present. See here, the generally what are the faults in the project, students? Can anybody tell? Generally, the most common faults are nothing but errors. What are the most common errors in the program? What are the most common errors in the program? You will not do any error. You will not make any error when you write a program. When I ask you to run the program, to find the square root for a quadratic equation. This is my question. So when you start when you start executing this program, then what type of error you may make? Yes, students, is my question is clear?
Syntax error, ma'am.
Yes, good. Syntax error. Some comparison error. Instead of less, when I want if I want to give less than or equal to, by mistake I may give only less than. Correct, no? So like comparison mistakes also I may do. Logical error also I may do. Correct, no? Logical error. Typo error. Yes. In the printf statement, if I want to print the result is I wanted to print the statement the result is, instead of writing result is, I may do some spelling mistake. That spelling mistake is nothing but a typo error. So generally what happens when we do you can take a small program, or you may take a larger program. When we start developing the project, we may do some common mistake like syntax error, logical error, or comparison error, typo error. So these types of error we may do when we execute a program. So here some of the terminologies related to false-based testing. So the original program. So the original program, the program may be in the form of C or Java or C++ or COBOL. So here they have just taken example only two programming languages, that is C and Java. So the original program may be in the form of C or Java. The program location, the program a region in the source code. The precise definition is defined relative to the syntax of particular programming language. Typical location are statements. The program location is nothing but the statements in the program, arithmetic expression, Boolean expression, And calls, procedure calls are nothing but the functions, methods. So methods we call in the main program, no? So procedure calls, these are all the program location. The alternative expressions, in a program there are n number of expressions will be there. So some alternative expressions. And the alternative program, a program obtained from the original program by substituting an alternative expression for the text at some program location. And the distinct behavior of an alternative program are for a test. Okay. Um, so the distinct behavior of an alternative program. So some what is distinct behavior is nothing but sometimes what we do, we alter the program. We'll do some minor changes in the program. That minor change is nothing but the alternative way of writing the program. So these are all the terminologies of fault-based testing. Yes, this is very important. Mutation. What is mutation? Anybody? What is mutation? Come on, tell me, no? What is mutation? Yes, students, can you hear me? Is my voice is audible? Benita? Chaitra?
Yes, ma'am.
What is mutation?
Ma'am, variation in the program.
Yes, good. So mutation is nothing but the variation in the program or modification in the program. So mutation analysis is the most common fault of software fault-based testing. A fault model is used to produce a hypothetical faulty programs by creating a variants of a program under test. So generally what happens, we when we write a program, see here only I have taken this, I'll repeat the same example. So to check whether the given year is leap year or not, so generally the most common formula, the general formula, what we use is we divide the year by 4. If remainder is equal to 0, then I say the given year is leap year. If remainder is not equal to 0, then the given year is not leap year. But this condition will not satisfy the complete, will not satisfy all types of input. For example, if I give 1900 as a 1900 year, if I take, then 1900 is not a leap year. But according to this logic, what logic? That is year mod 4 is equal to 0. The logic is year mod 4 is equal to 0. This is the most commonly generally used logic to find the given year is leap year or not. But if I take the input as 900, but according to this logic, the remainder will be 0. But 1900 is not a leap year. So to enhance this program, so what I am doing, I am dividing this year by 4, 400 and 100, so that I can get a get a proper output or correct output for all types of inputs. For all types of inputs. So here I'm doing the changes in the program. So when I do the changes in the program, it should not affect to the behavior of the, or it should not affect to the output what we are expecting. It should not affect that. It should not affect to the behavior of the program. If it is affecting the behavior of the program, then this mutation will be rejected. If the modification or the mutation which we have applied, if that is affecting to the output of the program, or if that is affecting to the behavior of the program, then that mutation will be rejected. Understanding student, that mutation will be rejected. If that is, if see, if for this program, initially what I have taken, year mod 4 is equal to 0. What variation I have added? Year mod is equal to 4, year mod is equal to 4, and I am checking year mod 400 and year mod 100. So extra two conditions I'm applying. After applying this extra two condition, it is not affecting to the behavior of the program, so this mutation will be accepted. If I divide year by 3, if I divide the year by 3, then it will affect the output of the program, then this mutation will be rejected. Getting students? So this mutation will be rejected. Some of the terminologies of this mutation analysis: the original program under test. Mutation is nothing but the changes in the variables, changes in the statement, changes in label and condition, and distinguished mutation, equivalent mutation, and mutation operator. So these are all the terminologies of mutation, and a small code snippet for mutation. Fault-based adequacy criteria. Adequacy is nothing but the capacity. Student, adequacy is nothing but the capacity. The fault-based capacity criteria also we can say, that is a select mutation operator. Select mutation operator. So what operator we are implementing? So what operator we are implementing? Select the mutation operator. Generate mutants. Distinguish mutants. A mutant can remain live for two reasons. What are those two reasons? The mutation can be distinguished from the original program, but the test suits. But it should suits with the test case, and the mutation cannot be distinguished from the original program by any test case. So these two are the conditions. And generally what in mutation, we apply the operator. We apply the operator means we extra operator we are implementing. So we have to see what operator we are including, or what operator we are including in the original program, and that implementation of our extra operator will become a mutant. So that is a mutation of the program. And distinguished mutation. Distinguished mutation is nothing but the original program, what was the original program and what enhancement or what mutations I have done, so that we have to distinguish. So variations on mutation analysis. Can anybody tell what is this? Because this I have already see. What is in revision class? Nobody is responding. Whatever happened in the regular class, the same thing is happening. Just I'm only explaining everything. You people are not responding for anything. And if you have doubt also, if you people are not asking, then what is the use of revision class, students? And when I ask you to submit some assignment, for that also, you people are not submitting properly. Yes, how many of you submitted the last assignment? What program I have given? I forgot. Now program kottidde. Quadratic equation I gave now.
No, ma'am. Decision tables.
Yes, yes. Decision tables. How many of you submitted? Let me check. Risk management. 26 students have not submitted. Abhinav is here. Abhinav, Aishwarya.
Ma'am,
Abhinav,
today I will submit, ma'am.
why today this risk management when I gave this assignment? Huh? When I gave this risk management? Let me check the date, wait. December 26th December I gave this risk management, and today is 30th December. Yes. Amrish. Arjun. Why Arjun? Are you there? Arjun is there? He's not there. I think he left the meeting. Benita. Bhargavi. Benita was there. I saw her. In the beginning of the class, she was there. Now, when I start taking the attendance, then again everybody will come and join for the class. Okay, in 10 minutes, I'll finish the revision of the 5th module. Then I'll come back to this. So variations on the mutation analysis. What is scaffolding? Can anybody tell? So scaffolding is nothing but when we develop a project, a complete project will not be tested at a time. Correct now, students? A unit by unit will be tested, then it will be integrated, and then the complete system will be tested. In scaffolding also the same thing is happening. Here the complete program is not given for the testing. So during development, so how we do the development, step by step, we do the first home page, then the second page, then the third page, like a step by step we do the development. So in scaffolding, how we do the step by step development, like that, step by step testing will be done. So at a time, a full complete system is not available for testing. So the part of testing is nothing but a scaffolding. The part of testing is nothing but scaffolding. So here the scaffolding may be the interactive program, or it may be a graphical interface. If I designed a home page, in the home page, what are the icons are available, what are the hyperlinks are available, everything will be tested part by part. A complete project or complete application will not be tested at a time. During development, a portion of the project will be tested. That portion of the project testing is nothing but scaffolding. Capture and reply. So generally what happens when before giving the project to the customers or to the end users, the developer and the test engineers has to check the project. So when they start checking the project, when they start using the project, they will come to know what error, what mistakes, or where the project is going wrong, where the functionality is not working properly. So they capture the error, or they capture the fault, and immediately they have to reply, because they have to give the project to the customers. They have to give the project to the end user who has given the developer and test engineers to develop this project to them. They have to give the project. So what they do, they capture the error and they immediately they'll respond back to the error. The quality is very much important, students. We may do a simple project, or we may do a complex project. The quality is very much important, and the quality cost are very much important. And to check all this, there are three teams are there: internal team, external team, and the corrective team is there. So they will check whether they have done the project properly or not. So the IBM has provided the clean room. So in clean room also, we are going to check how whether the program is running properly. We do statistical testing, quality clarification, implementation, development. Everything will be done here. Next, we have plan. uh, Whatever the project we develop, so first we'll do the planning. So based on the plan, we start executing the project. So the planning is very much important. What is risk planning? Anybody? Rashmi?
Ma'am,
What is risk planning? Risk will be there in our daily life also, in the project also. Risk will be there. So I'll give a simple example. Assume that we are traveling. So we are traveling to one place to other place by train, by road, or by air. So we are traveling. So maybe it is a assume that it is in winter season we are traveling. So what we do? So we don't want to take risk. We don't. It may be a road travel or it may be a air travel. We don't want to take risk. So we'll take our luggage with necessary accessories. It may be sweaters or any other thing. So we don't want to take risk when cold increases. So similarly, in the project, when we start developing the project, we don't want to take any risk in the project. So we will plan how we want to execute the project. So everything will be planned. So one person will be, or the manager, you can say a manager will be there. So that manager will be checking whether that he will be controlling the project, and he will be checking, monitoring whether the project is running properly or not. Students, one second. So whatever the project we do, we have to make the planning of a project, and based on the time and cost. So here the time and cost are very much important, students. So based on the time, we have to do the planning. So there are a few types of risk planning: personal risk, technical risk, development risk, execution risk, requirement risk, scheduling risk. So these are all the types of risk. Scheduling risk. So these are all the types of risk. Monitoring the process. A quality manager will be there. He will be monitoring the process, how the project is running, whether it is satisfying the needs of the customer or not, whether the scheduling is done properly, all the corrective measures have taken properly or not, and everything will be taken monitored by the quality manager. So if anything goes wrong, if anything is not sufficient, if any errors or any ambiguity, anything is not clear in the project, then if it is not reaching the milestones, then it will be reported by the quality manager. So he will report these things are not working properly, and by the developer and by the test engineer, they will again they will plan according to that, and they will try to modify the project. And the quality manager will check whether the work is uh, uh, whether the work is reaching the deadline on time, how they have planned, whether it is whether this is running according to the plan or not, all the activities and all the functionality in the project is working successfully or not. If because of any problem, if anything is terminating in between or any error, everything will be taken checked, monitored by the quality manager. See, I gave this example. See, here I have 4 forms in the project. See, I have given the links now from first form to second form to third form. Like this, it is moving. Sometimes what happens from first form directly, if it is coming to the last form, then the flow is not correct. The flow is not correct. Something went wrong. It is not for working. The project is not working according to our requirement. So that will be that will be monitored by the quality manager, and he will report to the developer and the test engineer the functionalities are not working properly, so that they can do the modification. Improving the process. So to improve the process, the first thing is, what are the faults? First we have to understand that where I have done the mistake. So once I check where I have done the mistake, then I can able to improve the process. And next is, okay, this time I have done the mistake, next time I should not repeat this. How to prevent
Ma'am,
the,
Ma'am, your
yes,
screen is not visible.
share the screen, ma'am.
okay. Now is it visible?
No, ma'am. It's visible.
Hello.
It's
Yes,
visible,
ma'am.
ma'am.
Yes, ma'am.
You want me to repeat from that risk planning once again? Yes, no need, no need, no? So the improving the process, in the improvement of the process, first we have to understand what are the faults. Faults are nothing but the errors, what mistakes or what errors I have done. So once I'll come to know the reason for the mistake or faults in the program, then I can able to then I can able to give the proper solution. And next is, how could faults are prevented. So generally we say the prevention is better than what? Complete the statement. Prevention is better than, ready? Yes, students, can you hear me? Students, can you hear me? Am Am I audible?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
So generally we say one statement, no, prevention is better than, next.
Cure.
Hmm? Prevention is better than cure. So doing the mistake, after doing the mistake, instead of correcting, so we can avoid the mistakes, no. So once I come to know what mistakes are there in the program, what is the reason for that mistake, so we'll try to resolve the mistakes, we'll try to resolve the errors or faults. Then how could we prevent the errors, or how could we prevent the faults? So we have to, these two things are very much important in the improvement of the process and the quality team. So to run the project, a single person cannot do the project, so there will be a team. To each team a different work will be allotted, and each team has to work properly. So in our team, if one person is not working properly, then the blame will come to the entire team. So in the team, the ego should not be there. Whatever, if I don't know some functionality, if I don't know the how to write the logic for something, then I have to ask my team member, so that we should complete the project, or we should complete the task within a given time. So the teamwork is the quality of the team is very much important. Organizing the document. So generally, it may be, whether it is a small project or the larger project, the documentation is very much important. So we have to prepare the document, so that for the next project, we can refer this project as a basic information. Or if any new user, or if any new person join to the project, then they should not, nobody has a time to explain that person all the functionality. If we maintain the record, if we maintain the document, if any new user reads that document, then they'll get some idea what functionality, or how, what is the problems, what is the statement of this project, and what are the tools and technologies, and what are the functionalities, functional requirements, non-functional requirements, everything will be available in that report, so that they'll get the clear idea about the report. So the documentation is very much important. So the document will follow a standard format for all the document. A predefined standard format will be there, and they have to follow the consistency to maintain the document. So in the report, the test analysis, the test plan, everything should be available. So this is the end of 5th module. Students, if you don't ask any questions, then if I do revision 3-4 times also, there is no use. You people are not responding for anything, and you are not asking any questions, just simply you're just listening. Cancel attendance. Answer attendance. One minute. Benita is there. Abhinav is there.
Yes, ma'am.
Why you have not submitted the assessment? The risk management assessment. Answer attendance, students. Asta, Abhinav.
Present, ma'am.
Why you have not submitted your assessment? Risk management assessment. Aishwarya,
Present, ma'am.
Amrish, Anu,
Present, ma'am.
Arbaz, Arjun.
Present, ma'am.
Why you have not submitted, Arjun?
Ma'am, I submitted. Check, ma'am.
Now you have submitted, I think. Oh, now
Yeah,
you have
ma'am, like-
submitted. Ashok,
Present, ma'am.
Benita,
Present, ma'am.
why you have not submitted the assessment? I asked you 3-4 times, you did not respond. Only for the attendance people are responding, I think. Bhargavi, Chaitra,
Bhavisha present, ma'am.
Bhavisha,
Present, ma'am.
Dev, Diksha.
Present, ma'am.
Where is your assessment, Diksha?
Ma'am, today I will send, ma'am.
Junjar, Deepika L,
Present, ma'am.
Deepika M,
Present, ma'am.
Murli,
Present, ma'am.
Gangubai,
Present, ma'am.
Gudia,
Present, ma'am.
Harshit,
Present, ma'am.
Junjar, absent. Kavya,
Present, ma'am.
Kishore, Lata,
Yes, ma'am.
Manisha, Manjunath,
Yes, ma'am.
Nayana,
Present, ma'am.
Nilanjan.
Yes, ma'am.
Where is your assessment, Nilanjan? Why you have not submitted?
Ma'am, today I will send it.
Nishant,
Present, ma'am.
Pavitra,
Present, ma'am.
Maithili,
Present, ma'am.
Priyanka, Nishant. Where is your assessment? Nishant,
Ma'am, today I will submit, ma'am.
Priyanka,
Yes, ma'am.
Pavan.
Present, ma'am.
Where is your assessment?
I will submit, ma'am.
Akash,
Present, ma'am.
Rajeshwari,
Present, ma'am.
Rakesh, Ramya.
Present, ma'am.
Now you have submitted, Ramya.
No, ma'am.
Okay. Rashmi,
Present, ma'am.
Ravi Shankar,
Yes, ma'am.
Rizwan.
Present, ma'am.
Yakapa submit madila assignment.
I will submit, ma'am, today.
Vishal,
Present, ma'am.
Savita.
Yes, sir. Yes, ma'am.
Vishal,
Yes, ma'am.
where is your assessment?
Ma'am, even I need to submit.
Savita,
Yes, ma'am.
Shruti,
Present, ma'am.
Shruti, your assessment.
Ma'am, today
Sneha,
I'll submit, ma'am.
Yes, ma'am.
Spurti,
Present,
Spurti,
ma'am.
Spurti assessment.
Ma'am, I will submit today.
Srinidhi, Srinidhi, Srinivas,
Present, ma'am.
Sunil, Sunil, Vaishnavi,
Present, ma'am.
Vinny.
Present, ma'am.
Where is your assessment, Vinny?
Ma'am, I'll submit.
Okay, students, you know your test dates, no? 4, 5, 6 is your test. Any doubt you have? If you have any doubt in the syllabus, you can ask. No doubt. No doubt, huh? Okay, students, I'll stop here. See you in the next class.